Great. Now we have these examples. In the previous video, we said that we shall be looking at other examples, and these are some of the examples that we have here. Let's look at example A and B. So in this question, we are asked to determine whether or not each of them or the following are what, one to one. All right, great. We've done this in our previous lesson. We looked at how we can prove algebraically when a function is one to one or not. Okay, and that is what we are going to use to prove or to determine if these functions are one to one. Okay, in our previous lesson, we said that for a function to be one to one, it should be. So let me begin with our solution. Good. We said that for a function to be one to one, then algebraically, if you have f at a should be equal to f at what? B, which implies that a should be equal to what? B. All right, so that is what we are using the same to what? To determine if this or that is what? One-to-one mapping. All right, so let's begin with our A. Once we are given this function as f at x is equal to x squared minus 3 all divided by x squared. All right, so we are going to substitute a for x in the equation and also substitute what? B for x in the equation. Then we equate the two to determine whether it is one-to-one function. All right, great. So if that is the case, then it means my x should be a, at the same time my x should also be what? B. So that is what I'm going to do now. In this case, I'll put a here, which should be equal to, I'll put b here, b here. So this is what we are going to do. We are going to have a, which says we should square it. So I will square it, minus 3 all divided by a squared again should be equal to b squared minus 3 divided by what? B squared. Yes. Now, when we have this, how do we go about it? So this is what? Equations involving what? Fractions. Equation involving fractions. So as always people say, if you have this, you do cross multiplication, which I said I don't know where the cross multiplication is coming from. What we are only doing is that we are going to find the LCM of the two denominators, and after getting that, we multiply through. All right, we multiply the LCM by each side of the equation. Now what will be my LCM for this? LCM, which will give me, okay, now since we have these which are not the same, we can multiply them to get what? The LCM. So my LCM is going to be a squared b squared. This is what I'm going to multiply by each side of the equation. So I'll multiply a squared b squared by this a squared minus 3 all divided by a squared, which should give me what? The same a squared b squared multiplying the expression b. So this is what? Multiplication, multiplying the expression b squared minus 3 all divided by b squared. Okay, now once I'm going to multiply, I'll only look at what is here and then cross this out. I'll also cross this out because they are common. All right, once I cross this out, I will be left with b squared multiplying a squared minus 3, which is equal to a squared multiplying what? The expression b squared minus 3. Good. Once I have this, I can just go ahead and open the bracket. That is what? Basic what? Expansion of brackets. Remember what we did in the algebraic expression. When you have this, all that you do is you just what? Open the bracket by multiplying what is outside the bracket term by term. What is outside the bracket, each term in the by each term in the what? Bracket. So b times a gives me what? A squared b squared. Then b squared times negative 3 gives me what? Negative 3b squared, which is equal to a squared times b squared gives me a squared b squared, and then a times negative 3 gives me what? Negative 3a squared. So let's see if we can group like terms. You realize that we have a squared b squared here. So I can decide to maintain this here and then transpose this to the other side so that I can clear this out. I will therefore write negative 3b squared, okay, which is equal to a squared b squared minus a squared. I'm just transposing this here, minus b squared. Then we have minus 3a squared. So that this one will go because they are like and they are the same. Okay. I will therefore have 3b squared is equal to negative 3a squared. Okay. All that I will do is I will just divide both sides by negative 3. Okay, negative 3, which I can cross this out, having b squared is equal to a squared behind. Okay, now once I have this, I can also interchange their position. Since they are all positive numbers, I can just rewrite it as a squared is equal to b squared. Are we still done, or we still have to further simplify? Yes, we still have to simplify, because per the definition of 1 to 1, we are saying that a should be equal to b, but we have, in our case, we have a squared is equal to b squared. So when we have it like that, we can take square root of both sides, since we have each of them squared or squared here, which is equal to, now anytime you take square root of an expression, you take square root of both sides of an equation, then it becomes a plus or minus square root of b squared. Alright, so that this one will go and then this one will go. We then have a is equal to plus or minus b. This suggests that we have a is equal to positive b or a is equal to negative b. Now we have two solutions or two roots, okay, for a. These are what we have. Based on this solution, can you say that it is 1 to 1? Let's go back to the definition of 1 to 1. We are saying that for a function to be 1 to 1, f at a should be what? F at b, which implies that a should be b. A, which is positive, should be equal to b, which is also positive. But in our case, we have one of the solution being a equal to a positive b. But looking at this one, we have a is equal to what? Negative b. Since this changes the whole situation, then we can conclude that the function or the relation is what? 1 to 1. Therefore, we can say that, therefore, the function f at x is equal to x squared minus 3 all divided by x squared is not 1 to 1. Yes, it's not, because I've already explained. If we had gotten only this, a is equal to b, then it would have been what? 1 to 1. But since we are having a is equal to negative b, then we can say that it is 1 to 1. All right, now let's try the second one. Let's look at the second example. Okay, let's look at the second example. Great. So this is the second example. All right. So in this example, we are given f at x being equal to what? The expression 2 all divided by 5 plus x squared, given the condition where x is what? Greater than 0. All right. Great. So we are going to prove whether, or we are going to determine whether this one is also what? 1 to 1. All right. Good. As we always say that algebraically, for a function to be 1 to 1, then f at a should be equal to what? F at b. That gives what? A should be b. So we are going to do all this. All right. Great. So it means I'm going to substitute a values for this and b values for that. I will just proceed and write 2 divided by 5 plus a squared, which is equal to 2 divided by 5 plus b squared. Okay, now what do? I will take the LCM and multiply the LCM by each side of the equation. What is my LCM? My LCM is, since this and that are not the same, I can just find the product of the two and use as my what? LCM. So this becomes my LCM base the product of the two expressions, or the denominator becomes my LCM. So this is what I'm going to multiply through by each side. Okay, I will just write 5 plus a squared multiplying 5 plus b squared, all multiplying what? The expression 2 divided by 5 plus a squared, which should give me the same expression 5 plus a squared multiplying 5 plus b squared, all multiplying the expression 2 divided by 5 plus b squared. Great. So let me just look at it. You realize that we have 5 plus a squared, which we have this here also common, so we can cross this out, and when you come here we can also cross this out, leaving this behind. It therefore means that we are going to have the expression 2 multiplying another expression, what? 5 plus b squared, which is equal to 2 multiplying the expression 5 plus a squared. Okay, yes. Now let's open the bracket. 2 times 5 gives me what? 10 plus 2 times this gives me what? 2b squared, which is equal to 2 times 5 gives me what? 10. 2 times a squared gives me what? 2a squared. Here we come again, we can group like terms. I will just maintain my 2b squared and transpose this 10 to the other side of the equation. So I can have 10 minus 10 plus 2a squared, where this one crosses out. Then I have 2b squared is equal to 2a squared. All right, I can just divide both sides by 2 and have my 2b squared. Okay, so I'll just have my 2b squared is equal to a squared. I will just change their position as this, which means the same. All right, because if b squared is equal to a squared, then a squared is also equal to what? B squared. All right, great. Now here we come again. Still the definition is saying that to show that it's 1 to 1, it should be a is equal to b, not a squared is equal to what, b squared. So we can further simplify it by taking square root of both sides. All right, which gives me plus or minus square root of b squared. This one will go, this one will go. Then we have a is equal to plus or minus b, which suggests that a should be equal to positive b or a should be equal to negative b. Now this is similar to the previous example we did in our previous video, or in the first example. Yes, this one is similar to the first example we did. We realized that after solving, we had a being equal to what, positive b, and a also what, negative b, and we concluded in our previous example, or the example a, that since we are getting one negative, then the function is not what, 1 to 1 function. But come to think of it, let's look at something here. In this example 2, the b part, you realize that there's a certain condition. Yes, this condition is given, and that condition changes the idea that once you have one of them being negative, then it is not 1 to 1. Okay, this is the condition given. Okay, x is greater than 0, and you know what it means. It means that we are looking at positive numbers. It means the answer you get, we must get what, positive numbers. When we say x is greater than 0, it means that we need numbers that are greater than 0, numbers that are more than 0. And what are those numbers? We can think of 1, 2, 3, 4, and the likes. All right, good. So once all these numbers are positive numbers, then we can only consider this as our answer and ignore this. Okay, we ignore the negative part, since this condition demands we look for the positive one. Then we can conclude that the function f at x is equal to 2 on the expression 5 plus x squared is 1 to 1. So take note of the two examples. All right, the first one we got the same answers, the second one we have gotten the same answers, but they have different conclusion. The same answers, but not all of them are 1 to 1 based on the condition. Because this one we have this condition, that's why we are saying that it's 1 to 1. If there were not any condition attached to this question, then we would have said that this is not 1 to 1, because this is also what, negative. And that ends today's lesson. All right, so we shall be looking at other types of function in our next videos. We are going to look at many to one function, onto function, even function, odd functions. We shall also be looking at domain of a function, range of a function, the zeros or the root of a function in our next videos. So stay cool and wait for the videos of the next concept. All right, this is Mazris TV. I'm your facilitator, Ivan Sokan. So don't forget to subscribe to my channel, like and share. You can also add your submission, whatever questions that you have. You can go to the comment section and post it there. We check them and help you out. So see you next time. Bye bye.